some organization 2123. You'll get familiar with it later. And today I will present you my talk about the revolution of UI development for set-top boxes. So if you have any questions, in the end, feel free. So first of all, who knows what is the set-top box? I believe a lot, no? But you definitely use it. So set-top box is just a box, thanks to which we can take a quite old TV, we can add the box, and we can get something like smart TV. It means that your old TV can support some personal video recordings, movie stores, search, recommendations, whatever. Plus to it, of course, you have your regular television as well. Technically, from UI point of view, this is a front-end meetup, the UI has two main goals on a set-top box. First of all is to render the UI, actually. And second one is just to react on some keys when you press some keys on RCU, or if you have some mobile devices, a remote control, or any other, or voice, whatever. So it sounds very easy, but it's not so easy. Just some insight into the past. This is the approximate schema of how it worked before, quite a long time ago. So your RCU just sends some signal to the box. Box sends that signal to some cloud. In cloud actually renders your UI and sends back to the box, and box presents it on the TV. This approach has one of the biggest advantages of this approach is that your set-top box could be very slow, because it has nothing to do other than just transmit the signal from cloud to the TV. It doesn't process any data, it doesn't render anything. It's just a video signal, so any TV can do it actually. But of course, the number of users was growing, and the more consumers you have, the bigger your cloud should be. And of course, that approach was not even for a long time. Later on, boxes were developing, and I called it type 2A. In short, it was possible to write some UI renderers on typed languages for set-top boxes, for any embedded device. Mostly was used C, C++, Java. There are several frameworks for it. OpenGL has a special version called OpenGL for embedded systems. And it was working fine. The only issue was that you have to have quite strong, let's say, C++ developers to develop some UI stuff, which now works, as you know. And actually, the army of front-end developers was growing bigger and bigger. And as a logical further step of it was the development of browser. So, putting browser inside the set-top box. Right now, there are two major players on this scene. First one is Qt browser, made by Metrological. Second one is actually the evolution of it. It's called WPE, the web platform for embedded. It's actually just the browsers that can be opened on some embedded device in the full screen mode and present some HTML and execute some JavaScript. That's just a briefly. So first, what is a Qt browser? It has WebKit under the hood, which is not good yet. That's not IE. It has remote web inspector. It was quite easy to develop, to debug, to investigate something. It's built with Nokia Qt framework. I didn't decide is it pros and cons with it. But last release was in 2013, so it's quite old, and you can forget about all modern JavaScript and CSS features like const-led, OES6, etc. It's not really web-friendly. Web-friendly, I mean, it has no events, for example, keys events, that we all know in our regular web applications. But you have to subscribe to some special debug comments, etc., etc. So it was quite difficult. And the biggest problem was that browser plus UI occupied around 200 megs of memory. Just for your understanding, regular box has around 1 gig. Yeah, so 1/5 part was taken just by browser and the UI, which was of course not really good. But there are several boxes in fields that work with that browser and works quite fine. So the next step of evolution was, as I said, WPE browser. It has many benefits. It's a WebKit fork, so it's completely built on top of WebKit. It's not a wrapper around WebKit, but it's just a fork. It's open source, so you can easily find it on GitHub. It also has remote web inspector. Last commit was yesterday, so it has quite stable releases. It's under control and updated. It's developed. It's mobile friendly. They integrated, for example, key events, so you can now write just a regular web application without any dependencies on some middleware stuff, etc. And the empty browser took only 35 megs of RAM. But browser plus UI still 180. Of course, it was, again, not really acceptable, but again, there are several boxes, several generations of boxes that do work with such approach with that browser. So now, just a brief story how we developed our UI for Qt browser and then for WPE browser. So initially, we had a prototype on Backbone. It was quite nice until we faced some issues with performance. Even though Backbone is not the heaviest framework, but still we had, because the configuration of box is not performant at all. Later on, it was developed into some custom solution. It was also performing better than Backbone solution because it was fully under our control, all rendering stuff, all page lifecycle, view lifecycle, everything. But our team was growing, and from time to time it was harder and harder to maintain so big team working on the same project. So finally we switched to React plus Redux, and it showed us approximately the same performance as our custom framework. But at least, thanks to component-based architecture of React and of Redux, we were able to work around probably 50 developers on one project. This is the typical development environment of developing UI for set-top box. So you have your own laptop, your own machine. You should have a set-top box. And simply set-top box in this case is just a reverse proxy. So you can open on your laptop just page which is served by box, which actually takes it from your laptop. You still need a box in the middle because sometimes you want to send some commands to middleware, to the box actually, and this stuff is done, it should be on the same domain simply as a box. So yeah, we all know, of course. So lessons that we learned. First of all, workarounds are the must, unfortunately. We spent a lot of time, we tried our best to get rid of workarounds, try to avoid them, but you always need these workarounds. In any place, actually, in CSS, in JavaScript, whatever. Redux store could be slow. That's a real example from our development. It happened that when you have around 150 reducers or even more, and you run your application on a set-top box on an embedded device. So one action going through all the reducers may take up to 100 milliseconds. So yes, of course, it's not applicable. Memory leaks are important, and they are, especially in Qt browser, it has a lot tons of memory leaks. So that's actually the next point. We learned how WebKit JavaScript core works. Because you have to be very attentive to the code, especially to tell the JavaScript that you write, because it's not just a web application. You always can refresh your tab in browser, and okay, it will work from scratch, but it's not the case with embedded devices. So later on, after browser's era, That was a back to basics step. There are just some examples of ready-to-use solutions. So what does it mean? Simply it was a two-way rendering. So RCU still sends some signal to your box, and box itself can render the UI in any way, doesn't matter. But let's say you don't want to boot the browser because it takes 200 megs of memory. In that case, you just put some applications that should be run in browser to the cloud. So simply, when the signal from RCU reaches the box, it goes to the box itself, so box can change UI if needed. And plus to it, it can send some signals to cloud, which can render some applications. It is working right now in field, again on some boxes. And the whole UI is rendered by the box itself, but some applications like Twitter, for example, or some quizzes, they are rendered on the cloud and just transferred as a video signal to the box. Later on, some application producers said that, okay, we don't want to be hosted in the cloud. Mainly it was Netflix and YouTube. They told, no, we want our applications to be run exactly on the box, not in the cloud, not anywhere else, exactly on the box. That was mainly related to security issues, etc. And it led us to the next step. So this is the situation that we have right now. We use so-called EFL. It's an entitlement foundation libraries. It's a set of libraries. They are open source. And yeah, they are mainly supported by Samsung. So this is the picture from their side. So you have your application, and behind it you have just several layers of some helpers, some code actually, that can render your JavaScript object to the something meaningful on the UI on the TV. So what is EFL? EFL is, as I said, it's a set of libraries written mainly in C plus some C++. They have bindings to C++, to Python, to JS. Not so good, but still, yeah, they do their best, they hope. But for Python are really nice. And it's already used by FreeFR. It's a set-top-box company in France. And actually all Tizen-based products from Samsung. So if you have your refrigerator from Samsung, or smart TV, or whatever, based on Tizen, most probably it's used by, it uses EFL. What is bad about EFL, you still need to patch it. Unfortunately, there are not so often releases of EFL, and thanks to the fact that it's open source, we can patch it, we can add fixes on our side, we can add some features on our side, and that's actually what we do. So this is the example. To draw just a red background with the word Gdansk in black on a TV, you have to write approximately this code. Yes, that's in regular HTML, that would be just one tag. Yeah. So that shared node, that's exactly our wrapper around the native EFL bindings to JavaScript, where we exactly add some features that we need. But in general, and everything, yes, everything in EFL consists of nodes. They have their own controls. So if you develop something for Tizen, then yes, you can use that controls. But if you need something custom, you have to use so-called node. You can think about it as just a div in HTML, but imagine that you do everything in divs. If you want to put image or text or some background or whatever, you have to use node. So the red background is also node, which consists of node for text. Text itself is also node, and blah blah blah. What is and good and bad is that it has absolute positioning. Yeah, you may see that all the positioning is in absolute values. Why it's good? Because you don't care at all about your markdown. Yeah, you don't work with percents or EM or VW or something else. You just set pixels and forget about it, and it will be rendered exactly on the same, on the required place. It can be done in this way because of scaling. So your box can scale the rendered image to the resolution that your TV has. Yeah, so we can develop our UI for resolution 720p, but the box itself can scale it to, let's say, 4K. Yeah, of course, some images would be not so good, but still the main UI components will work fine. So now our typical dev environment looks like that. So we no longer can render something on a laptop. Now only box and only on TV can render something. So yeah, every our developer, for example, has its own box, its own TV set, and own laptop. We simply develop on the laptop, upload that code to the box, just to start some applications on the box, and voila, we have some image on the TV. And yes, there are some alternatives to EFL. Most known are Luna and PXSim. We also tried to make some custom solutions, some custom renderer. We have appropriate people who can transform actually JavaScript objects with some properties to some GPU related stuff. But as a result, we still stick to EFL, at least for now. In the future, so third-party applications, there are big plans to integrate tons of applications that looks like native, like Twitter, Netflix, YouTube already there, so games, news applications, etc. And also, one of the focuses is gaming. So we have already several prototypes based on NVIDIA Grid. So the main idea of it is that on the back end you have something like Steam, which works for all users in your cloud. And it can do exactly as it was in the very beginning of my story. You send some key, it goes to cloud, it renders game for you and transforms and makes the transition of the picture to your box. It allows us actually to run very high-performant games, I don't know, like World of Warcraft, for example, on a set-top box which has only one gig of RAM. And also we have a prototype with connected Xbox joystick to our box. And yeah, of course, together they can make some kind of gaming platform from your TV, from your set-top box. That's mainly it. Thanks. If you have any questions.
Okay. Where is React in all of it? Okay. Where is React in all of it? Because you mentioned React, that you ported your application from Backbone to the custom and to the React, and it was a previous solution, right? You cut it off in your parent in the future solution.
Yes.
Yeah, so what we did, we just refactored our application, our custom application, the whole application into React based. So, and yes, it was running in a browser.
And then you rewrite it again?
No. Thanks to, well, as you know, React is just a rendering layer, so some pieces of business logic were migrated to our application. Now it's just a regular Node.js application, actually. So we have an box Node.js, and we run just a Node.js application, which is not a web server, as many may think that Node.js can be used as a web server. But yeah, some pieces of business logic indeed they migrated to our code, but not rendering stuff, obviously. Any other questions?
Yeah, one question about positioning absolutely. Is it possible? The scaling is possible because we always have an assumption that TV sets Hertz always the same screen ratio, 16:9?
No. At least we have a switcher between 16:9 and 4:3. And yeah, so basically in that case, it's all work is on a set-top box side. So it simply scales and zooms as it thinks it's right. Yeah, so we develop as a 16:9, just a regular screen resolution. But yeah, all the rest stuff is done by the box itself, by middleware. So we don't care about it. The only problem is images, actually.
Is there a high demand on the market on such devices nowadays? Because is there high demand on the market on such devices nowadays? Because more and more people are just replacing their old TVs with the smart TVs.
Yes, but in some countries, for example, you buy not just a device, yeah, but you sign a contract with a content provider. For example, in Poland, it's UPC. So when you sign the contract, you say that, okay, I want to watch these channels. But together with these channels, you have to obtain this device because it also decodes the signal from servers. But together with the device, you have all the features that it provides. But in general, yes, the device I think is quite high, at least from television's company. I can't tell you some numbers now, but yes.
Like in Poland, if you sign for Orange or UPC, you don't have choice. You should have this box. Like exactly this box, actually. Okay, any other questions? Okay. Thank you very much.
Thanks.
So in 2 minutes we will have second talk.